Good afternoon, all of you. In yesterday's lecture, we have discussed about the heat transfer through plane wall. So, in that, we have considered one plane wall, and our aim is to calculate the heat conduction through that particular plane wall. So, we have considered in the plane wall having thickness L and temperature at the one phase is T1 and temperature at the another phase is T2. So, our aim is to calculate the how much rate of heat transfer that particular heat conduction equation in Cartesian
Hey, your
coordinate system. Okay. So general heat conduction equation in Cartesian coordinate. That equation we have written, and from that equation we have considering the some assumptions. Sound is audible? Hello, Shinde.
सर
Sound is
खूप
audible?
खरखरण्याचा आवाज येतोय.
Clearly, sir.
पुन्हा एकदा द्यायचे
Okay,
का?
I will check. Okay. Now it is audible.
Yes, sir. Yes, sir.
Yes, sir, it is audible now.
Okay, Madan. Now check.
Audible, sir, audible.
Okay, so for that we have written the general heat conduction equation in Cartesian coordinate system. So what is that equation? Dou square T upon dou x square plus dou square T upon dou y square plus dou square T upon dou z square plus Qg by k is equal to 1 upon alpha into dou T by dou T. So by using that equation we have to derive the heat conduction through the plane wall. Okay, Madan, sound is audible? No?
Yes, sir, it is clearly audible.
Okay. So, what are the different assumptions we have considered? That is, first assumption is heat conducted without internal heat generation. Means we have to considering the plane wall. So, whatever the heat generated within that element, we have to consider that heat generation is zero. Then, what is the second assumption? Second assumption is heat conducted only in x direction. So basically, in general heat conduction equation in Cartesian coordinate system, we are considering the three direction x, y, and z direction. But calculating the heat transfer rate through the plane wall, we are considering the only one direction, that is x direction. Similarly, we are considering the heat conduction is at steady state. Okay, so whatever the factors with respect to time, that factor becomes zero. Okay, so by using these terms, we have written the equation, that is dou square T upon dou x square is equal to 0, because all the remaining terms becomes 0. That is, anything with respect to y is 0, anything with respect to x is 0, because we are considering the one dimensional heat flow is there. Then internal heat generation is 0, therefore Qg by k is equal to 0. Okay, then steady state is there, so dou T by dou T is equal to 0. Okay, so what is the remaining term? That is dou square T upon dou x square is equal to 0. So from that, so we are considering the partial derivative, because for these small elements, but we are now considering the total plane wall. So for that, there is a need of to consider the total derivative. So we are converting the partial derivative into the total derivative. So the equation becomes d square T upon dx square is equal to 0. Then we are taking the integration 2 times, then we get the equation, that is T is equal to C1x plus C2. And we are considering the boundary conditions from the diagram. If x is equal to 0, then temperature is equal to T1, and if x is equal to L, then T is equal to T2. So by putting these conditions into equation number 3, we get the values of C1 and C2. So what is the value of C2? C2 is equal to T1, and C2 is equal to T1, and C1 is equal to T2 minus T1 divided by L. Then we have put this value of C1 and C2 in equation number 3. Then we get that the value of temperature distribution throughout that particular plane wall. So what is that equation? T is equal to T2 minus T1 divided by L into x plus T1. So this is the standard equation, that is y is equal to mx plus c. So this is the equation of straight line. So from that we said that for the plane wall, what is the temperature distribution? That is linear temperature distribution is there for the plane wall. Okay, so our aim is to calculate the rate of heat transfer, that is Q is equal to minus K into A into dt by dx. So we know that the equation of temperature, that is T is equal to T2 minus T1 divided by L into x plus T1. So we have to take the derivative of that, then we get the equation that is dt by dx is equal to T2 minus T1 divided by L, and then we have to put that values into the equation, then we get the value of equation for the heat transfer, that is Q is equal to K into A into T1 minus T2 divided by L. T1 minus T2 divided by L. So that is the equation for the heat conduction through the plane wall. Heat conduction through the plane wall. Okay, so this is our equation for the heat conduction through the plane wall. So this is the plane wall, considering the heat transfer through that plane wall is Q. So our aim is to calculate the rate of heat transfer through this plane wall. So for that we have considering the general heat conduction equation in Cartesian coordinate system. Then we have considering the assumptions. We have considered three assumptions, that is internal heat generation is 0, Qg is equal to 0, one dimensional heat flow is there, and steady state is there. So because of that we get the final equation, that is d square T upon dx square is equal to 0. Then we have taking the 2 times integration of this, then we get the value of T is equal to C1x plus C2. Then we have applying the boundary conditions. What are the boundary conditions from the diagram? X is equal to 0, then T is equal to T1, and if X is equal to L, then T is equal to T2. So from that we get the value of C1 and C2. C2 is equal to T1 and C1 is equal to T2 minus T1 divided by L. So we are putting this value into the equation, then we get the value of T, that is T is equal to T2 minus T1 divided by L into X plus T1. So this is the equation same as the Y is equal to mx plus c. So therefore temperature distribution for the plane wall is linear temperature distribution is there. So our aim is to calculate the rate of heat transfer. So Q is equal to minus K into A into dt by dx. So T value is known, so we are taking the derivative of T with respect to x, then whatever the value we get, that we have to putting into the equation number 6. So from that we get the value of Q. So heat transfer rate for the plane wall, what is the standard equation? That is K into A into T1 minus T2 divided by L. K into A into T1 minus T2 divided by L. So this is the standard equation to calculate the heat transfer rate through the plane wall. Okay, after that we have discussed about the thermal diffusivity. So basically what is meant by thermal diffusivity? So in general heat conduction one concept is there, thermal diffusivity. So instead of rho c by k we have put the 1 upon alpha, that is alpha is nothing but thermal diffusivity. So what is meant by thermal diffusivity? Thermal diffusivity is defined as the ratio between thermal conductivity and thermal capacity. Thermal conductivity and thermal capacity, so that is alpha is equal to k upon rho c. So what is the another definition? It is the ability of the material to conduct the heat with respect to ability to store the thermal energy. So means we have comparing, that is heat is more conductive or heat is more stored. That comparison we have to understood by using that concept, that is thermal diffusivity. So we have taking the two examples, one example for the temples and for temples and forts. So for that there is a value of less thermal diffusivity, because in that case thermal conductivity is less as compared to the thermal storage capacity. So whatever the example we have taken that stones we have to using for the forts and temples having thermal diffusivity is less, because whatever the stones we are using in the temples and the forts having thermal conductivity is less as compared to the thermal storage capacity. So because of that inner temperature is less as compared to the outer temperature. And similarly we have discussed about the second example, that is metallic steel. So in this case the thermal diffusivity is higher, because in this case maximum heat is transferring because of the conduction as compared to the heat storage. So these two examples, from that we have to understood what is meant by thermal diffusivity. And when small thermal diffusivity is there, when we have to use using the big stones in the forts and the temples. Okay, So this is about the thermal diffusivity. Then next point, write down heat conduction through the composite wall. So write down composite wall. Next point, composite wall is there. Okay, so in last lecture we have given the heading as a heat transfer through the plane and composite wall. So first part we have completed, that is heat conduction through the plane wall. Now we have to calculate the equation for the heat conduction through the composite wall. Okay, so write down the definition of the composite wall. Write down what is meant by composite wall. Composite wall म्हणजे काय असणार आहे? A wall built up of combination of two or more units of different types of material that are bonded together. म्हणजे आपण we are considering the plain wall. So in that case only one material is there. Now in the composite wall we have to consider two or more than two units are there and they are bonding to each other and having different material is there. म्हणजे एक जशी प्लेन वॉल असणार आहे तशाच आपण काय करणार आहे, त्याच्यापेक्षा दोन किंवा दोन पेक्षा जास्त मटेरियल एकमेकांना आपण अटॅच करणार आहे. And we have to calculate the heat transfer rate through that particular composite wall. So this is the diagram for the composite wall. So in this case A, B, C is there. So these three are different layer. A is different layer, B is different layer, C is different layer, means having different material, and these three materials are bonding together. So this type of shapes is nothing but composite wall, and our aim is to calculate the heat transfer rate through this particular composite wall. समजते बघा, त्यावेळेला सिंगल प्लेट असणार आहे त्यावेळेला आपण त्याला काय म्हणतोय, प्लेन वॉल म्हणतोय. And suppose two or more units are bonded together, then we said that that is nothing but composite wall. ज्यावेळेला डिफरंट मटेरियलचे दोन किंवा दोन पेक्षा जास्त लेयर्स आपण एकमेकांना अटॅच करणार आहे, then that component is nothing but composite wall. So for the composite wall we have to calculate the rate of heat transfer. Okay, so first of all we have to write down the definition of the composite wall. So what is meant by composite wall? Write down a wall built up of a wall built up of a wall built up of a combination of a wall built up a wall built of a combination of two or more units two or more units two or more units of different two or more units of different types of material different types of material that are bonded together that are bonded together that are bonded together okay. So this is the definition for the composite wall. समजलं का बघा, प्लेन वॉल मध्ये आपण फक्त एक लेयर कन्सिडर केलेला. फॉर द composite wall we have to considering the two or more layers and which are bonded together having different materials. So our aim is to calculate the heat conduction through a composite wall. So write down next line, next heading, heat conduction through a composite wall. Heat conduction through a composite wall. Heat conduction through a composite wall. Okay, तर ही जी काही composite wall असणार आहे, so how many heat will be transferred from this particular composite wall? We have to calculate by using the derivation. We have to get first of all the equation for this composite wall, and from that equation we have to solve the different problems related to the composite wall. Okay, so write down first line, consider the transmission of heat consider the transmission of heat through a composite wall consisting of number of slabs. Okay, consider the transmission of heat through a composite wall consisting of number of slabs. So in this case we are considering the three slabs, that is A, B, and C. These are the different slabs having different materials, so that they are having different thermal conductivity is there. So all of you draw this diagram, composite wall. Okay, draw this diagram. So there are three layers. First layer is A layer, second layer is B layer, and third layer is C layer. So we know that for the plane wall, heat distribution is linear. So temperature is changing with respect to thickness, that is in the form of linear. So T1 to T4, the temperature is changing linearly. So T1, T2, T3, and T4. So T1 and T2 are temperature distribution for the layer A. Then for the layer B, T2 and T3 is there. And for the layer C, what is the temperature difference? T3 and T4 is there. K is nothing but thermal conductivity for the layer A. Then Kb is nothing but thermal conductivity of layer B. And Kc is nothing but thermal conductivity of layer C. And we have given the notations, that is 1, 2, 3, 4. Whatever the surfaces we have considering the, for that we have given the names, that is 1, 2, 3, and 4. Then what is the thickness of the layer A, that is La. Then what is the thickness of the layer B, that is Lb. And what is the thickness of the layer C, that is Lc. Okay, so heat transfer throughout this composite wall, that is nothing but Q. So at the inlet, what is the heat, that is Q. And at the outlet, what is the heat, that is Q. Okay, and what about the temperature? So T1 is greater than T2 and is greater than T3 and is greater than T4. That is the temperature distribution. Along the thickness, what will happen? The temperature will be reduces. So T1 is greater than T2 is greater than T3 is greater than T4. Okay, so this is the diagram of the composite wall. Below that we have to draw the diagram in the form of electrical system. जे आपण इलेक्ट्रिकल जो सब्जेक्ट असतोय, तर त्या सब्जेक्ट मध्ये जसं आपण डायग्राम काढतोय रेझिस्टन्सच्या फॉर्म मध्ये. सो इन दॅट वे वी हॅव टू ड्रॉ द डायग्राम. दॅट इज heat transfer rate is Q at the inlet, and then heat transfer at the outlet is Q. Okay, then temperature distribution for the first layer, that is in between T1 and T2. And what is the resistance? That is thermal resistance for the layer A. Then similarly for the resistance 2, that is thermal resistance for B, and temperature range is T2 and T3. Similarly for the layer C, what is the resistance? That is thermal resistance for the C, and what is the temperature range? That is T3 and T4. So in the layer below the layer A, there should be thermal resistance for the layer A. Below the layer B, there should be thermal resistance B, and below the layer C, there should be thermal resistance C is there. Okay, in that way we have to draw the electrical diagram, electrical resistance diagram. जसे आपण composite wall ची diagram काढल्या, तीच diagram आपण कशाच्या फॉर्म मध्ये ड्रॉ करू शकतो? in the form of electrical system. Okay, so draw the electrical system diagram below this composite wall. Okay, after completion of diagram, put the message in the chat box, then I will proceed. Okay, diagram is over, or anyone is remaining? Okay, diagram is over. All of you put the message in the chat box. Shall I proceed? Okay, so this is the diagram of the composite wall. In this diagram, there are three layers A, B, C. temperature distribution for a layer A is T1, T2, for B T2, T3, and for layer C T3, T4. K is thermal conductivity of layer A, Kb is the thermal conductivity of layer B, Kc is the thermal conductivity of layer C. Then thickness of layer A is La, thickness of layer B is Lb, and thickness of layer C is Lc. And heat transmitted through that composite wall is nothing but Q. And similarly, we have drawn the diagram for the in the form of electrical system, that is in the form of thermal resistance. So for the plate A, what is the resistance? Thermal resistance A. For the plate B, what is the thermal resistance? Thermal resistance for plate B, and for thermal resistance for plate C. Okay. So next line, write down the meaning of each term. Write down. Let LA, LB, LC. Let LA, LB, LC is equal to thickness of slabs A, B, C respectively. LA, LB, LC is equal to thickness of slabs A, B, C respectively. Then write down K, KB, KC. K, KB, KC is equal to K, KB, KC is equal to thermal conductivity of metals, thermal conductivity of metals, thermal conductivity of metals A, B and C, thermal conductivity of metals A, B and C, A, B and C. Then next line, T1, T4 is equal to temperature at wall surface. T1, T4 is nothing but temperature at wall surface 1 and 4 respectively, 1 and 4 respectively, 1 and 4 respectively. The next line, T2, T3 is equal to T2, T3 is equal to temperature at interfaces, temperature at interfaces 2 and 3 respectively, temperature at interfaces 2 and 3 respectively. Okay, so these are the parameters. So from that diagram we have to understood LC is nothing but thickness of the slabs ABC. Then KC is nothing but thermal conductivity of metals ABC. Then T1, T2 is nothing but wall surface temperature at point A and point 1 and point 4. And T2, T3 is nothing but temperature at the interfaces. Means in between AB section T2 is there, and in between B and C section T3 is there. Okay. Write down the next line. Since the quantity of heat transmitted per unit time through each slab is the same. समजते बघा. What is the meaning of this? That is Q amount of heat काय होणार आहे तर transmit होणार आहे. So that amount of heat transferred first of all from the layer A, then same amount of heat is transferring through section B, and then same amount of heat is transferring through section C. म्हणजे प्रत्येक लेयर मधून जी काही हीट ट्रान्सफर होणार आहे ती काय असणार आहे, सेम असणार आहे. दॅट इज नथिंग बट Q. म्हणजे हीट ट्रान्सफर फ्रॉम दी सेक्शन A, QA इज इक्वल टू QB इज इक्वल टू QC इज इक्वल टू काय असणार आहे, Q असणार आहे. कारण प्रत्येक लेयर मधून जी काही हीट ट्रान्सफर होणार आहे ती काय असणार आहे, सेम असणार आहे. कारण इनपुटला हीट किती ट्रान्सफर झालेली आहे, Q आहे, आणि आउटपुटला किती आहे, Q आहे. So whatever the heat transferring through the each layer, that heat will be same for the each layer, that is ABC. Okay, so write down the, since the quantity of heat transmitted, since the quantity of heat transmitted per unit time, since the quantity of heat transmitted per unit time through each slab is same, through each slab is same, through each slab is same, full stop. Next line, therefore from Fourier's law, from Fourier's law, from Fourier's law, what is the equation of Fourier's law? Q is equal to minus K into A into dt by dx. So write down the Fourier's law. Q is equal to minus K into A into dt by dx. Q is equal to minus K into A into dt by dx. So by using this equation, we have to write down the equation for the each layer. पण त्या प्रत्येक लेअर मधून जी काही हीट ट्रान्सफर होणार आहे ती काय असणार आहे? सेम असणार आहे. फर्स्ट ऑफ ऑल, we have to write down the equations for the each layer. Okay, so write down the heat transfer through layer A. Heat transfer through सेम असणार आहे म्हणून आपण नोटेशन काय दिलेलं आहे? Q दिलेला आहे. So Q is equal to for the layer A. Q is equal to what? What is the equation for the layer A? Q is equal to K into area into T1 minus T2 divided by LA. So this is the equation for the plane wall. Plane wall साठी आपण equation derive केलेलं आहे. तेच equation आपण इथं लिहिणार आहे. Okay. So section A we have to consider that section A is nothing but it is a one plane wall. So for that plane wall we have to write down the equation of the plane wall. Plane wall चं आपण equation derive केलेलं आहे. K into T1 minus T2 divided by L. ते आपल्याला कुठल्या सेक्शन साठी लिहायचं आहे? A सेक्शन साठी लिहायचं आहे. So we have to write down the KA suffix A म्हणजे काय असणार आहे? Thermal conductivity of layer A. So write down K into A. हा K च्या सफिक्सला A असणार आहे, लक्षात ठेवा. थर्मल कंडक्टिव्हिटी ऑफ सेक्शन A into area into T1 minus T2 divided by LA. Thickness of that composite wall or that layer A. Similarly, you have to write down the equation for the layer B and then you have to write down the equation for the layer C. Difference काय असणार आहे? तर टेम्परेचर रेंज चेंज होणार आहे, त्याचा थिकनेस वेगळा असणार आहे, त्याची थर्मल कंडक्टिव्हिटी वेगळी असणार आहे. सो Q is equal to KB, that is thermal conductivity of section B, into area into what is the temperature range for the layer B, that is T2 minus T3, and what is the thickness of the layer B, that is length of B. Okay, thickness of section B, that is LB. Okay, similarly we have to write down the equation for the layer C, heat transferring from that particular layer C. So Q is equal to what? Kc into A. Kc is nothing but thermal conductivity of the section C, then area into what is the temperature range for the layer C, that is T3 minus T4, T3 minus T4, T3 minus T4 divided by LC. T3 minus T4 divided by LC. ओके, तर त्या प्रत्येक लेयर मधून जी काही हीट ट्रान्सफर होणार आहे ती सेम आहे. ओके, सो व्हॉट इज द इक्वेशन? That is all heat transfer from the each section is same, so therefore we have to write down the equation, that is Q is equal to हे सगळे जे असणार आहे त्याची हीट ट्रान्सफर सेम असणार आहे, म्हणजे हे तिन्ही इक्वेशन काय असणार आहेत? सेम असणार आहेत. सो राइट डाउन द Q is equal to what? Q is equal to K into A into T1 minus T2 divided by LA. ही सगळी इक्वेशन इक्वेट करा, इक्वेट दी ऑल द इक्वेशंस, equate the all equations. Okay, equate all the equations. Okay, Q is equal to K into A into T1 minus T2 divided by LA is equal to KB into A into T2 minus T3 divided by LB is equal to KC into A into T3 minus T4 divided by LC. Okay, then we have to rearranging above equations. Write down next line, rearranging above equations, rearranging above equations, rearranging above equations. So whatever the equation we have written for the layer A साठी जे काही आपण इक्वेशन लिहिलेलं आहे, whatever the equation we have written for the layer A, rewrite that equation. So how to rewrite that equation? तर layer A साठी आपण इक्वेशन लिहिलेलं आहे, Q is equal to K into A into T1 minus T2 divided by LA. Now we have to write the equation for the T1 minus T2. So what is the equation for the T1 minus T2? So T1 minus T2 is equal to what? Q into this LA is coming at the left hand side divided by K into A. So write down the equation. rearranging above equation. So from that T1 minus T2 is equal to what? Q into LA divided by K into A. What is the equation for the T1 minus T2? Q into LA divided by K into A. So this is the equation number 1. T1 minus T2 is equal to Q into LA divided by K into A. Similarly, we have to write down the equation for the layer B, that is T2 minus T3 is equal to what? T2 minus T3 is equal to Q into LB. T2 minus T3 is equal to Q into LB divided by KB into A. Divided by KB into A. Okay. Similarly, we have to write down the equation for the section C. Right from the screen, T3 minus T4 is equal to what? Write down. Write down all three equations. Okay. So then this is the three equations we get from the layer A, layer B, layer C. T1 minus T2 is equal to Q into LA upon K into A. Similarly, T2 minus T3. Similarly, T3 minus T4. So adding equation 1, 2, and 3. Add this equation 1, 2, 3. Adding equation 1, 2, and 3. Adding equation 1, 2, and 3. Adding equation 1, 2, and 3. So add the left hand sides of the equation, that is T1 minus T2 plus T2 minus T3 plus T3 minus T4 is equal to add the right hand sides of the each equation. So when the adding at the right hand side equations, then we have to take the Q as a common, and the remaining terms we have to take in the equation. So Q we have to take the common. Q is equal Q into bracket LA upon K into A plus LB upon KB into A plus LC upon KC into A. So add these add these three equations. Okay, add these equations 1, 2, and 3. So minus T2 is there, plus T2 is there, minus T3 is there, plus T3 is there. So minus T2 plus T2 will be cancelled. Then minus T3 and plus T3 will be cancelled. So what is the remaining term? So write down T1 minus T2 is equal to Q into bracket T1 minus T2 is equal to Q into bracket LA upon K into A plus LB upon KB into A plus LC upon KC into A. ओके तीन इक्वेशन ऐड करा ऐड केल्यानंतर T2 कॅन्सल होणार आहे T3 कॅन्सल होणार आहे सो फ्रॉम दॅट वी गेट द इक्वेशन T1 minus T2 is equal to Q into bracket LA upon K into A plus LB upon KB into A plus LC upon KC into A. Okay, our aim is to calculate the rate of heat transfer, means we have to calculate the value of Q. Okay, so that's why we have taken the Q as a common from the right hand side. So our aim is to calculate the value of Q. Okay, so from that equation we have to write down the equation for the Q. Okay, so write down the equation for the Q. So Q is equal to what? Q is equal to T1 minus T4 divided by that right hand side term, that is LA upon K into A plus LB upon KB into A plus LC upon KC into A. Okay, so this is the equation for the rate of heat transfer through the composite wall. Composite wall जर असेल तर त्याच्यासाठी काय इक्वेशन येणार आहे, Q इज इक्वल टू म्हणजे इनलेटचं जे काही टेम्परेचर असणार आहे T1 मायनस आउटलेटचं जे काही टेम्परेचर असणार आहे दॅट इज T4 डिवायडेड बाय LA upon K into A plus LB upon KB into A plus LC upon KC into A. Can anyone tell me what is this LA upon K into A? म्हणजेच काय असतंय? Anyone? This is the equation of what? What is the another name for this term LA upon K into A? Anyone unmute yourself and tell me what is the another name for the LA upon K into A? First of all, you have to see that equation of heat conduction through the plane wall. At the end, instead of LA, L by K. L by K is nothing but, what is the meaning of L by K? Anyone?
Thermal resistance, sir.
Okay, thermal resistance. म्हणजे हा LA by K into A म्हणजे काय असणार आहे? This is the thermal resistance for the layer A. Then LB by KB into A, that is the thermal resistance for the plate B. And LC by KC into A is nothing but thermal resistance for the plate C. म्हणजे ज्या वेळेला आपण 3 प्लेट कन्सिडर करणार आहे तर त्या 3 प्लेटसाठी आपल्याला जर हीट कंडक्टेड किती आहे ते फाइंड आउट करायचं असेल तर त्यावेळेला आपण काय करणार आहे, जी काही पहिली प्लेट असेल त्याचं टेम्परेचर आणि जी काही लास्ट प्लेट असेल त्याचं टेम्परेचरचा डिफरन्स डिवायडेड बाय थर्मल रेजिस्टन्स ऑफ ईच प्लेट. म्हणजे ए प्लेट असेल तर त्याचा थर्मल रेजिस्टन्स प्लस बी प्लेट असेल तर त्याचा थर्मल रेजिस्टन्स प्लस सी प्लेट असेल तर त्याचा थर्मल रेजिस्टन्स. कारण आता आपण वी आर कन्सिडरिंग ओनली 3 प्लेट्स. सपोज so many times if there are 4 plates are there, if suppose there are 6 plates are there, at that time what is the final equation? Can anyone tell me if there are 4 plates are there, then how to write the equation for the Q? Anyone? In this case we are considering the only 3 plates are bonding together, but suppose there are 4 plates are there, then what is the change in this equation? Can anyone unmute yourself and tell me the answer? हे 3 प्लेटचं इक्वेशन आहे, ज्यावेळेला 3 प्लेट आपण एकमेकांना बॉन्ड करणार आहे. इफ देर आर 4 प्लेट्स देन व्हॉट इज द चेंज इन दिस इक्वेशन? कॅन एनीवन टेल मी? अनम्यूट युअरसेल्फ अँड टेल मी द आन्सर. इफ देर आर 4 प्लेट्स आर देयर,
T1 minus
ओके, T1 minus
T5 upon
हां
LA upon KA into A plus LB upon KB into A plus LC upon KC into A plus LD upon KD into A.
Okay, correct hai. So in this way we have to write the equation according to the number of plates. So this is the general equation we have calculated for the 3 plates are there. If there are 4 plates, then we have to understood what is the what is the change in that particular equation. If there are 5 plates, then if 5 plates are there, then what is the change in temperature? T1 minus T6 is there. 3 प्लेट असताना T1 minus T4 घेतोय. If there are 5 plates means T1 minus T6 is there. And how many thermal resistance are there? If 5 plates are there, then 5 resistance are there. Means these 3 terms are same. Then additional 2 terms are there. LD upon KD into A plus LE upon K into A. So in this way we have to write down the equation for the composite walls. This is the equation for the if number of layers is 3. If there are, if we have to write the equation for the number of layers 4, then we have to change it accordingly in that particular equation. Okay. So this is the heat conduction through the composite wall. So this is the standard equation for the heat conduction through the composite wall. Okay. So we know that LA upon K into A म्हणजे काय असणार आहे? Thermal resistance of plate A. Then LB upon KB into A is nothing but thermal resistance for the plate B, and LC upon KC into A is nothing but thermal resistance for the plate C. So all of you write down as thermal resistance of A is equal to LA upon K into A, because what is the standard equation for the thermal resistance? L upon K. So here LA upon K means this is the thermal resistance for plate A. So instead of that term LA upon K into A, we have to write down the thermal resistance of A, and instead of LB upon KB into A, we have to write down the thermal resistance of plate B, and instead of LC upon KC into A, we have to write down the equation as a thermal resistance for the plate C. So write down the First of all, you have to write down the what is the thermal resistance for A is equal to L upon K into A. Then thermal resistance for plate B is equal to LB upon KB into A. And then thermal resistance for plate C is equal to LC upon KC into A. Okay. So by using this term, how to write that equation? Q is equal to what? Q is equal to T1 minus T4 divided by T1 minus T4 divided by thermal resistance of plate A plus thermal resistance of plate A plus thermal resistance of plate B thermal resistance of plate B plus thermal resistance of plate C. Okay, so this is the standard equation for the heat transfer through the if three slabs are there or three layers are there. Can anyone tell me if there are n number of slabs, then what is the change in this equation? If there are n number of slabs. Okay, first of all, you have to complete this. Q is equal to T1 minus T4 divided by thermal resistance of A plus thermal resistance of plate B plus thermal resistance of plate C. So this is the standard equation in the form of thermal resistance. Okay, for the three layers are there. If suppose there are n number of layers, then what is the change in this equation? Can anyone tell me? If there are n numbers of layer, आता आपण 3 लेयरची प्लेट घेतलेली आहे, समजा तिथं n number of layers असतील, तर what is the numerator? Can anyone tell me what is the numerator? कोण सांगते? चितोळे. What is the value of numerator? ज्यावेळेला 3 लेयर्स असतात त्यावेळेला आपण न्यूमरेटर काय घेतोय? T1 minus T4 घेतोय. If there are n number of layers, then what is the temperature change in the numerator? What is that equation? Anyone? Vidate?
Yes. Yeah. Hello, sir.
Hello.
Sir, T1 minus Tn.
T1 minus Tn plus 1. करेक्ट आहे. ज्यावेळेला 3 लेयर्स असतील त्यावेळेला आपण काय म्हणतोय? T1 minus T4. If 3 layers are there, then T4 is there. If n number of layers is there, then instead of T4 what will happen? Tn plus 1 is there. जेवढे लेयर्स असणार त्याच्यापेक्षा एक तुम्हाला वाढवायला लागेल, कारण 3 लेयर असताना टेम्परेचर रेंज काय आल्या? T1 minus T4 आल्या. If n number of plates are there, then T1 minus Tn plus 1 is there. Okay, and at the denominator what will happen? At the denominator, summation of L by K changes from 1 to n. Okay, so write down this. This is the equation for heat transfer through 3 slabs, and then if there are n number of slabs, then Q is equal to what? T1 minus Tn plus 1 divided by जेवढ्या प्लेट्स असणार आहेत तेवढे काय असणार आहेत? तिथं थर्मल रेजिस्टन्सेस असणार आहेत. इफ n प्लेट्स आर देअर, then summation is changing from 1 to n L by K. ओके, म्हणजे n स्लॅब्स असणार आहेत तर तिथं n number of thermal resistances येणार आहे. Okay, so this is the standard equation if there are n number of slabs are there. Q is equal to T1 minus Tn plus 1 divided by summation it changes from 1 to n L by K. Okay, so this is the equation for the n slabs. If suppose they are given 5 slabs, then accordingly you have to write down the equation for that particular slabs. Okay, so this is the heat conduction through the composite wall. Composite wall कशाला म्हणायचं आहे? 2 किंवा 2 पेक्षा जास्त लेयर्स जर आपण एकमेकांना बॉन्ड करत असू डिफरंट मटेरियलचे, then that component is nothing but composite wall. That is nothing but composite wall. Okay, so this is the equation for the composite wall. Then write down next point. We have to write down the general equation for this. This is the one shape is given, that is the composite wall is given, having different shapes is given, and we have to write down the equations for the thermal resistance for this particular component. So write down next lines, स्टार मार्क करून लिहा. आपण एक कॉम्प्लेक्स शेप घेणार आहे आणि त्याच्यासाठी थर्मल रेजिस्टन्सेस काय काय असणार आहेत ते आपण कॅल्क्युलेट करणार आहे. ओके, सो राईट डाऊन. In order to solve more complex problem, in order to solve, स्टार करून ह्या नेक्स्ट पॉइंट आहे. In order to solve more complex problem, in order to solve more complex problem, in order to solve more complex problem involving both series and parallel thermal resistance, involving both series and parallel thermal resistance, thermal resistance, thermal resistance, thermal resistance. The electrical analogy may be used, the electrical analogy may be used, electrical analogy may be used, electrical analogy may be used. तर कुठलाही कॉम्प्लेक्स शेप दिला तर तुम्हाला पहिला काय लिहायचं इक्वेशन, यू हॅव टू राईट डाऊन दी इक्वेशन, स्टँडर्ड इक्वेशन Q इज इक्वल टू डेल्टा टी ओव्हरऑल. म्हणजे पहिली प्लेटचा जो काही सरफेस असणार आहे त्याचं टेम्परेचर आणि लास्ट फेस जे असणार आहे त्याचं टेम्परेचर ह्याचा डिफरन्स, म्हणजे त्याला काय म्हटलेलं आहे डेल्टा टी ओव्हरऑल. सो Q इज इक्वल टू डेल्टा टी ओव्हरऑल डिवायडेड बाय समेशन ऑफ थर्मल रेजिस्टन्स, समेशन ऑफ थर्मल रेजिस्टन्स. म्हणजे जेवढे काही प्लेट्स असणार आहेत त्या प्रत्येक प्लेटचे जे काही थर्मल रेजिस्टन्स असणार आहे त्याचे आपल्याला काय करायचं आहे, समेशन घ्यायचं आहे. ओके, सो हिअर वन कॉम्प्लेक्स शेप इज गिवन. So for that complex shape we have to write down the values for the thermal resistance for the each layer. So there are different layers are given. So draw this diagram. This is the complex shape. So this is the layer A, this is the layer B, then this is the layer C, then layer D is there, layer E is there, layer F is there, and layer G is there. And according to that layer, thermal conductivity is given. For layer A, K is there. For layer B, Kb is there. For layer C, Kc is there. For layer D, Kd is there. Okay, and for layer E, K is there. For layer F is Kf is there. For layer G, Kg is there. And for this total component, heat transfer through from this particular component, that is nothing but Q amount of heat is transferring from the component. So at the left hand side Q is there, and at the right hand side Q is there. And thickness is given. So for the layer A and B, thickness is LA is equal to LB. For the layer C, thickness is nothing but LC. And for the layer D, thickness is nothing but LD. And for the layer E, F and G, thickness is LE is equal to LF is equal to LG. That thickness of that particular layers is given. LA is equal to LB, then LC, LD. And then for the layers E, F, G, LE is equal to LF is equal to LG. ओके, तर हीच डायग्राम तुम्ही रेजिस्टन्सच्या फॉर्म मध्ये लिहायचे. म्हणजे लेयर ए आणि बी काय आहेत एकमेकांना पॅरलल मध्ये आहेत. समजतंय बघा, लेयर ए अँड बी इज इन पॅरलल विथ दी इच अदर. देन दिस लेयर ए अँड बी total component is in the series with the C. Then component C is in the series with the D, and this E, F, G are parallel with the each other, and that whole component is in the series with the D. Okay, so in that form we have to draw the electrical diagram in the form of resistances, in the form of resistances. म्हणजे A आणि B जो आहे तो पॅरलल मध्ये असणार आणि ओव्हरऑल AB हा काय असणार आहे, C च्या सिरीज मध्ये असणार आहे. C आणि D सिरीज मध्ये असणार आहे. डी हा EFG ला ओव्हरऑल मध्ये सिरीज मध्ये असणार आहे, पण हे EF आणि G एकमेकांना काय असणार आहे, पॅरलल असणार आहे. सो इन दॅट वे वी हॅव टू ड्रॉ दी रेजिस्टन्स डायग्राम, वी हॅव टू ड्रॉ दी रेजिस्टन्स डायग्राम. Okay, so this is the resistance diagram. A and B parallel to each other, and combination of these two is in the series with the component C, and C and D are in the series. Then E, F, G three are parallel to each other and in the series with the D. Okay, so at the inlet heat transfer is Q, and at the outlet heat transfer is Q. Okay, तर ए आणि बी शेपच्याच खाली रेजिस्टन्स ए आणि बी आला पाहिजे. सी कॉम्पोनंटच्या खाली थर्मल रेजिस्टन्स सी आला पाहिजे. देन ऍट द कॉम्पोनंट डी देअर शुड बी रेजिस्टन्स ऑफ डी अँड सिमिलरली फॉर द रेजिस्टन्स ई अँड एफ जी त्याच्या खालीच ते काय आले पाहिजेत रेजिस्टन्सेस आले पाहिजेत. ओके, सो इन दिस वे वी हॅव टू ड्रॉ द रेजिस्टन्स डायग्राम. म्हणजे वरची जी डायग्राम आहे ती हीट ट्रान्सफर डायग्राम आहे आणि खालची जी डायग्राम आहे ती काय असणार आहे इलेक्ट्रिकल सिस्टीमची डायग्राम आहे. म्हणजे हे दोन्ही सेमच असणार आहेत. जसं हीट ट्रान्सफर होते तसं करंट ट्रान्सफर होते आणि रेजिस्टन्स काय करतोय अपोज करतोय. सो वी हॅव टू ड्रॉ द डायग्राम इन द फॉर्म ऑफ रेजिस्टन्सेस. meaning of these two diagrams are same. Okay, draw this diagram and below that write down the equations for the thermal resistances. Okay, up to this we have written. Reply me in the chat box. Shall I proceed? Now we have to write down the thermal resistance value of each thermal resistance. That is, what is the value of thermal resistance A, what is the value of thermal resistance B, what is the value of thermal resistance C, what is the value of thermal resistance D, then what is the value of thermal resistance E, then what is the value of thermal resistance F, and then what is the value of thermal resistance G. We know that what is the value of thermal resistance, how to calculate L by K. So what is the value of thermal resistance A? LA upon K into A. Similarly, write down the value of thermal resistance B, that is LB upon KB into A. Okay, so in that way we have to write down the value of each thermal resistance. Here areas also different because for the layer A, this surface is having area which is normal to heat flow, that is the different as compared to the layer B. So we have to take the different notations also for the area. So write down the values of the thermal resistance for the all resistances. Okay, so write down this thermal resistance of layer A, La upon K into area of section A. Then thermal resistance of plate B is equal to thickness of plate B divided by thermal conductivity of plate B into area of layer B. So in that way we have to write down the thermal resistance value for the each layer A, B, C, D, E, F and G. Okay, so in this way we have to solve the values of thermal resistance and put that value of summation of that thermal resistance in the equation and find out the Q value, that is rate of heat transfer through that particular composite wall. Okay, Deshmukh, unmute yourself. Deshmukh. Pratik. Tell me what about today's lecture? Summarize the today's lecture. Pratik Deshmukh. I think you are coming at the time of starting of the lecture and now you have joined the lecture. Okay, in between you are not there. Pratik, for attendance, you are coming there. Okay, all of you written this thermal resistance for A, B, C, D, E, F, G, and we have to put these values into the equation. So in this way, we have to calculate the values or heat transfer rate through read through the composite wall. Okay, so this is about the today's lecture. In next lecture we have to write down the, we have to solve the overall heat transfer coefficient, so that derivation we have to discuss in the next lecture. Overall heat transfer coefficient, that is capital U. Okay, so that derivation we have to continue in the next lecture. So thank you very much all of you. Put your roll numbers in the chat box.